Today our lesson is going to be on combining like terms, kind of like the other day in class when I was asking you if I could combine 4 clips to 1 pencil and tell you that I have 5 clips. Algebraic terms can be either a single number or a single variable. So an example of a single term would be 5 or x. Those would be a single term. A product of numbers and variables without any addition signs or any subtraction signs are also considered a variable. This is just one grouping. That would be considered one term. They can also contain powers. So this is considered a term and this is considered a term. The key part is that one term has no addition or subtraction. You might want to write that down, it might help you. If you're ever asked for the coefficient is always the number in front of the variable. So in this case, the coefficient is 6. This coefficient is 129. Now on B, it looks as if there isn't one, but if I were to ask you how many B's are sitting there, you would tell me there's 1 B sitting there, so the coefficient is 1. Some people think that the coefficient of B is 0. Is this also correct? If I have a B there, do I have 0 B's there? No, that is not the case. The word variable contains the word vary, which means it could change. So in this case, we call x a variable because I could say a bunch of different things about what x could equal. I could tell you that x equals 1. I could tell you that x equals 2. I could tell you that x equals 3. I could tell you all the different numbers that x could equal. I could plug in x as 1 down here, and I could say 5 times 1 is 5. I could tell you to plug in 2, and you could tell me 5 times 2 is 10. You could go through and you could plug in any number for x for these 3 cases, and you're going to get a different answer. Varying means to change. Something that doesn't vary or doesn't change is said to be a constant. A number that stands all by itself without any x's or y's or abc's or any other variables is said to be a constant. 7 is 7. There's nothing we're going to see that changes about this 7. There's nothing we're going to see that changes about this 1975. Here it says circle the coefficients. Remember, coefficients are numbers in front of variables. So we've got to circle those. The number in front of the variable is 43. Here, the number in front of the variable, it doesn't look like it's there, but it would be a 1. The next one, it doesn't look like there's a number in front of the variable, but there's a 1. And then over here we have 2 ABCs. So we have circled our coefficients. Now, the 43 and the 2 that are standing by themselves aren't considered coefficients because they don't stand in front of a variable. We're going to underline the variables. We've got x here, x squared here, and we have ABC over here. So we have underlined the variables. We're going to put a square around the constants, so the numbers that are standing all by themselves are 43 and 2, and we put a square around them so you can see. What does XYZ mean? Now the other day we did an example like this in class. Whenever you see letters standing next to each other, you have to think about what operation holds them together. It is as if this would be x times y times z. You could also do it like this, x in parentheses times y in parentheses times z in parentheses, but you have to multiply them together. Some people make the mistake of plugging in 5 for x, 6 for y, and 7 for z, and saying that xyz equals 567. What they forgot to do was put in the multiplication signs, which would give us a totally different answer. So in this case, we're doing 5 times 6 times 7. 5 times 6 gives us 30, and now we have to do 30 times 7. 3 times 7 is 21. Put in our 0. So it equals 210. In this case, we had 3 variables. We had 5, 6, and 7. We could plug them in and figure out what our answer is. Whenever you have one term, so it could either be a variable or a number, but if there's one term without addition or subtraction signs, it's called a monomial. Mono means one, so a monomial means one term. Two terms is called think about something that represents the number 2. That would be a binomial. Bi means 2, like bicycle, 2 wheels. Two terms would be if I were to put x plus 5. I've got a term here, and I've got another term here, and they're separated by an addition sign. So if anything is ever separated by an addition sign or a subtraction sign, it's going to be called a binomial if there are 2 of them. 3 terms, think tricycle or trinomial. Tri means 3. So I could have 3x plus 5y plus 4. I can't combine any of these together, so I have 1 term, 2 terms, 3 terms. If you have any more than 3 terms, they just call it a polynomial. Poly meaning many. So that would be like x plus y plus z plus a. That has 4 terms. It's more than 3. It's a polynomial. Now, when we're thinking about equations, you can think about going to the pig. Now, if this cashier, he's quite handsome if I do say so myself, if he went to ring all of this up, is this the easiest way for him to ring it up, or is there a faster way for him to do it? The faster way would be for him to say that I have 6 cans of baked beans, I have 4 things of milk, and 5 bananas. But if they're all scattered, he's ringing up 1 baked beans, 1 milk, 1 banana, 1 baked beans, 1 milk, 1 banana, 1 banana, and so on, and it's just taking him a long time. But if he groups together the like terms, it makes it a lot easier for him. We can simplifying expressions in the same way. So if we're looking here at this cart, we have all of these terms here. Think about the paper clips. We could add paper clips to paper clips, but we can't add paper clips to pencils. So what I'm going to do is I'm going to look here, and I notice that I have an X. I'm going to go down the line, the conveyor belt. We're going to see if there are any more X's. Look at, I've got plus 7 X's right here. So if I group those by each other, X plus 7X, then I can easily add them together. Then I have my y's. I'm going to look for my y's. So I have a y here, and I have plus another y here. So I'm going to put those next to each other. Finally, I've got 2 z's plus another z. So now that I've grouped them together, I can start to add them together. If I have an x and I add 7 more x's, how many x's do I have? You should say 8 x's. Now, if I have a y and I add another y, how many y's do I have? I have 2 y's. Now, if I have 2 z's plus 1 more z, I have a total of 3 z's. Now, my question for you is, can I say that I have 8 plus 2 is 10 plus 3? Do I have 13 xyz's? Can I put together 8 paper clips plus 2 pencils plus 3 pens and tell you that I have 13 pencils? No. Since they're not like terms, and x is not a y, which is not a z, then this would be my final answer. It's as simplified as it can get. So this is just showing you how the steps that I just went through. So we put the like terms right by each other, and then eventually we could add them together. When you get to your homework, you're going to have level 1 type of questions where you have to write an expression. So Mr. Bile had 6 neckties and 2 pair of pants. At a sale, he purchased 3 more neckties and another pair of corduroy pants. So what's going to happen is you have your original expression. 6, let me change that color. 6 neckties. I'm going to represent neckties with N, and I'm going to represent pants with P. So he has 6 neckties, plus he has 2 pairs of pants, plus then he gets 3 more neckties, plus he's got 1 more pair of pants. So now when I'm looking at this, you have to stop and think, what 2 things, or what 3 things, or what 4 things can we add together? In this case, what are our like terms? Well, I see this. I've got N's over here, and I've also got N's over here. So I've got 6 N's plus 3 more N's, and then I've got 2 P's plus another P. So I could combine my like terms. Let me change this color here to make it a little easier to see. 6 N's plus 3 N's gives us how many N's? We should end up with 9 N's. Plus, I've got 2 P's plus 1 more P, which is 3 P's. Now, if I stop and think about it, if Mr. Bile had 6 neckties and bought 3 more neckties, he should have 9 neckties, which is represented right here. If he had 2 pairs of pants and he bought another pair of pants, he should have 3 pairs of pants. I can't add neckties to pants, so this is my final answer. Combining like terms. So you always want to combine the things that are similar together. So think of it this way. If I had 5 N's and I added 5 more N's, what would I have? Should have 10 N's. Now here we've got negative 9 N's plus, there's no coefficient here, but we could put one in. We've got 1 more N. So negative 9N plus 1N is going to give us negative 8N. With the integers, remember you take the bigger minus the smaller, which gives us 8, and since there are more negatives than positives, our answer needs to be negative. Here I'm going to put my coefficient in. I've got 1x plus 8 minus 3x. Please notice that I took this sign with the 3x. It's not just a positive 3x, it's a minus 3x. And then I have my 8 and my minus 4. So I'm going to rearrange my equation. I'm going to put 1x minus 3x plus 8 minus 4. Now in this case, I've got 1x minus 3x. Right? Now it does not matter that we have x's. We're going to still follow our rules for our integers. So with subtraction, we can keep it, change it, flip it. If I have 1x and I add a negative 3x, I could off to the side do 3 minus 1, which is 2. Since there are more negatives, I'm going to have negative 2 x's, and then 8 minus 4 is going to give me a positive 4. This would be my final answer. Level 3 type of questions, we are going to involve the distributive property now, and then at the very end, we'll collect like terms. So remember, with the distributive property, I'm already getting ahead of myself here. So with the distributive property, we think of these parentheses as a party. So if I stop and look at this, whoever's directly next to the party wants in. So negative 3 has to shake hands with 7b, minus, and then the negative 3 also has to shake hands with the 9 before they can get into the party. This minus b is still off to the side. It's not included in there. So we should have negative 21b minus negative 3 times 9 is negative 27 minus b. Now, in this case, we can add the opposite, and we're looking for like terms. I've got some b's over here, and I've got a minus b over here. So I'm going to rewrite this up here. We've got negative 21b minus, I'm going to put the 1 in there, 1b plus 27. Well, if I took away 21 b's and then I took away one more b, I took away a total of 22 b's. We could add the opposite to see that. Negative 21b plus negative 1b is negative 22b, plus we still have that 27. We can't add the two together because one has a b, one does not have a b, and like we've said in class, you can't add a clip to a pencil and say that you have two clips. So this would be our final answer. On the next problem, you'll see that we have two sets of the distributive property. So we have to distribute for both of them first. So here, 5 has to shake hands with the 1, minus. The 5 has to shake hands with the x, plus now the 2 has to shake hands with the 6r, and the 2 has to shake hands with the 7. So I have expanded this all out, and now I'm going to simplify. 5 times 1 is 5, minus 5 times x is 5x, plus we've got 12r, plus we've got 14. Now when I'm looking here, the only things I see in common are this 5 plus the 14. That gives me 19. Now stop and think, can we add x's to r's? Could we add xylophones to radios and tell you that we've got 7 radios? No, not going to happen. So we've still got our minus 5x and we've still got our plus 12r. That would be our final answer. There's nothing more that we can do here. When you get to the level 4 types of questions, you're going to have to remember some of the things that you've learned in the past. So we have the word perimeter here. When I think of the word perimeter, I underline the R-I-M. R-I-M stands for rim. When I think of rim, I think of kind of like the rim of a basketball hoop. It's like all around the basketball hoop, which means that I have to add all around the sides. So for this particular problem, remember, we have been doing adding like terms, so that's what we're going to continue to do here. We have I'm going to start here, 5 h's plus 3 f's. Okay, so I wrote that down. And now we have to add 2 h's minus 2 f's. I'm going to move this down a minute. Oh, I can't. Okay, I'm going to rewrite this. So we have 5 h's plus 3 f's plus 2 h's minus 2 f's, and that's just right up here. Plus, we have right down here, we've got 3 h's plus f. Plus, over here, we have 6 f's. So I'm going to look and see what we have in common. I see h's here. We've got 5 of them. If I add 2 more h's, we're at 7 h's so far. Here we're adding 3 more h's. So now we're at 10 h's. I'm going to come over here. We've got 3 f's. If we take away 2 f's, we're at 1 f. If we add another f, we're at 2 f's. And if we add 6 more f's, we're at 8 f's. So 10h plus 8f would be our final answer. It's important that you're looking at whether or not you're finding perimeter or area. What is the total area? Please note that this one says area. So if I had to find the area of a particular shape, remember that is length times width. So I'm going to find the area of each small little section. If this is 8 over here, this is 8 over here. So here, for this first one right here, we're going to have to multiply 8 times x plus 2. Plus, we're going to have to add the second section over here, which is 8 times x. So here, you'll notice that we set up the distributive property. 8 shakes hands with the x, plus 8 shakes hands with the 2, plus we still have 8x. 8x plus 16 plus 8x is going to give us our like terms, 16x plus 16. If you have any questions on this, please do not hesitate. I'm going to write my email again, like I do every time, sullivana@milton.k12.wi.edu. and I should be able to get back to you as soon as possible. Okay, hope it goes well, and I will see you tomorrow.